by using the substitution x is 2 times tangent of u shows that this integral is equal to this. So since it is given the required substitution, we start as usual, dx over du, because it is given x is a function of u, so we need just derivative of x, and the tangent derivative is just secant squared, so it's 2 times secant squared of u. Hence dx is 2 secant squared of u du. And our integral becomes dx, it's 2 times secant squared of u du divided by x squared, it's 4 tangent squared, and root of x squared, it's 4 tangent squared plus 4. And you remember that 1 plus tangent squared is secant squared. So these 4 can be factored out, and it becomes just 2 here in front of root, and we can cancel this 2 and this 2 from the root. So it becomes just secant squared of u du, and 4 tangent squared, and it becomes root of tangent squared plus 1, which is secant squared of u, and a root, so it just secant. And it becomes just 1 secant in the numerator. Let's rewrite. So it becomes secant of u du divided by 4 tangent squared of u. And you remember that 1 plus tangent squared is secant squared, and tangent squared is secant squared minus 1, but this difference in the denominator, it's difficult. But another way is we remember that tangent is sine over cosine, so let's represent everything in terms of sine and cosine. So it becomes sine squared over cosine, or cosine becomes cosine squared becomes here, and secant it's 1 over cosine, and hence it becomes 1 over 4 cosine of u over sine squared. And using another substitution, for example, let v be sine u, then as usual, or just inverse chain, it's called the inverse chain rule. You can see the derivative of sine is cosine, so it becomes 1 over 4 d of sine of u over sine squared of u, and it looks like 1 over 4 dv over v squared. If it's difficult, do as usual, just another substitution, v to be sine, then dv over du it's cosine, and du it's dv over cosine, hence it becomes 1 over 4 integral cosine of u du, it's dv over cosine of u, and cosine of u cancels, over sine squared, it's v squared. It's v squared. So it's v to negative 2, and just integral, it's v to negative 1, and divided by negative 1, so just minus, and v to negative 1 just over v, and v is sine of u, and plus some constant. Usually if you meet something to some power, so usually we use substitution, this to be, in general it's called u, but here it's v. But I can see that derivative of sine is cosine, so cosine moves here, and actually you can see the required substitution if you don't use this inverse chain rule directly. In such a way you can understand what should be chosen as a u in general. So it's the derivative of sine, so you understand if you choose u to be sine, you get everything to be in terms of sine, something like that. And it is given that x is 2 times tangent, not substitution that u is something in terms of x, so that we can just substitute for u and to get the answer. But here we should get sine of u from tangent. And how to do that? Tangent of u is what, x over 2, and then you just consider right angle triangle, and there is such an angle u, so the tangent is x over 2, and you choose any ratio opposite over adjacent to be x over 2, and then just using the Pythagoras theorem to find the hypotenuse, and it's what, it's just root of x squared plus 4, and then just by definition sine of u is what, opposite over hypotenuse, cosine is what, adjacent over hypotenuse, and hence it becomes negative 1 over 4, and sine is x over, so it becomes here x squared plus 4 plus c. Let's check. Yes, it's correct as required. And that's all for this question.